Good morning, everybody, and welcome to the Gas Goes Green ENA Hydrogen Safety Mini Summit. And thank you very much for joining. Please ensure that you remain on mute and cameras off, apart from those that are involved in the panel session and the contribution, please. And that will help, hopefully, everybody's broadband, and that everybody will be able to see and hear the session very clearly. It's really great that so many people have are joining us today on such an important subject matter. The industry has a great track record on safety of continually improving through our safety management systems. And for the benefits hydrogen has to offer, safety has to be and is our #1 priority. That's why we're pleased to welcome you here today to talk about the work that the networks are doing on this critical opportunity to meet our net zero ambitions. We've got two parts to today's event: a panel discussion with industry leaders, with Rachel Morrison from Bloomberg News, to hear from those people. So thank you very much, Rachel, for chairing that session. And then a series of presentation on leading network hydrogen safety projects, where you'll hear firsthand from and question the teams that are working on those projects. But before I hand over to Rachel to start the first of the two sessions, there are a few words on housekeeping. So hopefully you will have noticed that we are recording this event. So if you don't want to be recorded, then you know what the option is there. But that will allow us to capture the discussions and the presentations and use them more widely. For the panel discussion, we'll be taking responses from those of you in the audience on Slido on key questions, and Rachel will tell you when we can do that. For the presentations, the group chat will be open for questions, so do post your questions and we'll pick out the best of them and put them to the presenters. But all joking apart, we will answer all of the questions that are asked, even if it's not in the session. We will follow up with those. So without further ado, I'd like to hand over to Rachel. Thank you, Rachel.
Hi, I hope everyone can hear me. Thanks very much, Chris. And welcome to the panel discussion of Gas Goes Green. So we're here to discuss hydrogen, and in a week where the IEA has said that gas boilers should be banned from 2025, it seems like a good time to be discussing the role that hydrogen can play in picking up in heating and also elsewhere in the gas industry. So here today with me is our panel from the gas industry who can offer a variety of perspectives. First, we have Mark Horsley, who's CEO of Northern Gas. We have Carl Arntzen, who is CEO of Worcester Bosch. We have Tony Green, who's hydrogen project director at National Grid Gas Transmission. And we have Dr. Fiona Phelan, who is a reader in sustainable behaviour at Leeds Beckett University. So thank you to you all for joining us. First of all, we're going to talk a bit about safety. Hydrogen is very flammable, and one of the first things that people ask about with hydrogen is whether there's a safety risk. And one of my editors in Austria always mentions Hindenburg. I know that Leeds Beckett have done some polling on this and public opinion, and perhaps Fiona, you could kick us off with some perspectives on your research and what people think about hydrogen, and also if you could tell us some of the differences between hydrogen and methane gas, that would be interesting to hear. You might be on mute, Fiona, if you're talking.
Yeah,
we can hear you.
Yeah, yes. Excellent. Yes, thank you for that. Yes, absolutely. I've been doing research over the last few years looking at public perceptions of hydrogen safety. Now, it's really interesting that you should say that about the Hindenburg, and that it's the first question that everybody asks is about safety, because that was kind of our assumptions when we started doing this research as well. You know, this is absolutely not what we found at all. In fact, it was completely the opposite, in that people tended to assume it's safe until they were prompted to think, well, do you have any safety concerns? And in that situation, typically quite a bit of head scratching and racking brains and really trying to dig up what the concerns that people have got. We have actually seen echoes of this in previous literature as well. So going back a few years, various studies done in Wales and up in Teesside, again, kind of finding that the researchers expected to find concerns about safety that people have. In practice, they don't. What we've actually found is that it's a low engagement topic. You tend to have problems even getting people to get engaged with the topic and interested in it, which is kind of a good thing. They assume that you turn your gas taps on, everything works fine, everything is safe, and people don't even know what's coming out of their gas taps. You said, what's the difference between hydrogen and methane? And we did actually ask our participants this. What is it that happens? Where does the gas come from? What is it? And again, a lot of head scratching and a variety of answers. Well, it just comes from the pipes. Doesn't it come from Russia? And absolutely no idea at all what is the gas in the gas taps. So when you talk about it's potentially going to be changed to hydrogen, people are, oh, right, yeah, okay. And as I say, it's only you need to engage with them and explain to them what is happening and why. And that's with the hydrogen. There's no release of carbon dioxide into the atmosphere when people heat their homes or cook using gas. That grabs them. That's the hook to bring them in. And then when they recognise that, then they become more interested in the topic. And quite frankly, most of them puzzled as well, as in, if we know about this and we know it's an alternative, then why isn't it happening already? Why is there still debate about should this happen? And I mentioned as well that they had to be prompted to think about safety, but the safety concerns were more about, well, what are the unintended consequences? What do we not know? What are we not anticipating that could possibly go wrong? No safety concerns about using hydrogen in the home. And the idea that, well, a very strong belief people had was that if it happens, then it will have been tested and it will have been found to be safe. This has been found internationally as well. There was an interesting study by Chen in Taiwan looking at public perceptions of domestic hydrogen safety. And the main thing that predicted that was the belief that organisations, if they're going to comply with international safety standards, then of course it will be safe. So that's kind of nice, because it means that in the UK, people thoroughly believe that our organisations, the hydrogen industry, will comply with international safety standards. And just one more interesting point about safety as well. So there were huge benefits, perceived benefits in terms of the safety of hydrogen, in that people, when they found out that there's no chance of carbon monoxide poisoning, that was seen as a huge benefit. And so kind of almost feel like I'm saying nothing to see here. In terms of public perceptions of the safety of hydrogen, there are very few concerns. Now, in our research, we brought together members of the public and hydrogen experts in deliberative workshops so that they could discuss the questions that they've got and any concerns, and hear about the tests and the plans. And certainly in that situation, no problem whatsoever. You did mention polling as well, though, and we also did a survey of the UK, a nationally representative survey sample. And we did find there's a small group of the population who are naturally resistant, who do tend to have safety concerns. It's relatively small, around about 12%. And these people who, well, they don't agree that climate change is caused by human mechanisms. And so if you believe that, I guess you believe that there's less requirement to do anything about it. For the rest of the population, very few concerns, and easily reassured once people know about the testing that is happening.
Thank you. And Carl, maybe you could tell us what the difference would be if you buy a hydrogen boiler or a hydrogen ready boiler. I mean, I saw some of your appliances at the high street in Cumbria and they look pretty similar to gas boilers. I mean, is that an important part of convincing people that this is easy and safe to kind of switch over heating to hydrogen?
There we go. Struggling to unmute myself as well. So yes, as you say, the beauty of repurposing the gas network towards hydrogen is that then the boiler itself, the early research that we've done is around 85–90% of the components are the same. And therefore, within the context of the physical size of the boiler, the way it looks, it is essentially exactly the same appliance. We're just burning a different type of gas inside it. So where all the challenges have come is around the combustion chamber itself. So where we ignite the flame, where we manage the flame and the combustion process. So that in those unique areas, we've had to change some of the technology, particularly how we sense the flame, because with natural gas, we use the carbon atoms to sense the flame. So clearly no carbon in hydrogen means we've had to just come up with a different way of sensing that flame and then monitoring and adjusting the combustion process. But overall, I think that translates then into a perfectly safe appliance, an appliance that is the same physical size and shape. And actually then the main beauty, as I see, of using hydrogen and hydrogen ready boilers is then the consumer will notice absolutely no difference whatsoever within the physical context of their home, and their behavior doesn't have to change either, which is a big challenge when you talk about other technologies, particularly low temperature technologies, where the consumer has to change their behavior. And then picking up on what Fiona said, you know, most of the safety challenges we've had historically with gas boilers is around carbon monoxide. And of course, you're generating no carbon monoxide whatsoever. So actually, our safety case to BASE indicated it was a safer appliance.
Thanks. I'm also interested in the grid and whether you know, the molecules of hydrogen are smaller, whether there's going to be leaks, you know, if we start blending or pushing lots of hydrogen through the system, and whether a lot of money needs to be spent on getting the gas grid ready for this. Maybe Tony or Mark, you might have a view on this.
I'm off mute, so I'll take it first. First of all, I think it's important to recognise what Fiona and has particularly said about safety. And I've only been in the sector for the last 10 years, spent the rest of my career in electricity. And I think what I noticed entering the sector was the preponderance for making sure that people were safe, both from workers in the organisations and customers at the other end. So I think in some ways what Fiona has said is a silent acknowledgement of how well these assets have been managed over the years, and the first journey into hydrogen has all been associated with the management of that safety. So answering your question, back in 2016, when we first did the feasibility study and the H21 project, the second phase immediately moved into the safety arena. So over the last 4 to 5 years, we have spent enormous amounts of effort, time, money, making sure those assets are as safe, and if not, and you'll probably hear that later on in the presentations, potentially more safe than methane we use. And the carbon monoxide cannot be overestimated in terms of what fatalities are caused from that carbon monoxide. So that has to really come into the balancing equation of something here that all it does is produce heat and water. So as an industry, yes, we will have to manage it differently, but I'm absolutely uber confident that we will get the same customer reaction in 10, 15, 20 years time as you have today with a methane. You will turn the boiler on, you'll accept it's safe, and it will be just business as usual. And what is also interesting, Rachel, when you started a conversation from the customer end, I think that that's a piece of the jigsaw that's probably been missing in the safety debate and the transition debate to date. So I think it's a really important starting point. So how does the customer feel about what we're doing? And as Fiona said, it was only when you started to talk about net zero that it really started to grab people's attention. So I'm absolutely confident with both the testing we're doing, the results from the testing, and the testing program we have ahead of us, that we can manage this in as safe, if not safer way than we do with methane. I don't know if Tony's anything to add to that.
Just to reinforce what you've said, actually, Mark, I mean, from the point of view of transmission, which is what I represent, we're just now moving into that testing phase where distribution has already been doing that now for a number of years. So Future Grid, which you'll hear about a little later on, is just starting construction, and we'll obviously be interacting then with the distribution network. So we'll be able to demonstrate end-to-end assets that have been carrying natural gas for many years here in the UK, repurposed to carry hydrogen, demonstrating the way they're going to behave. So we're not accepting it can be done on paper. We're actually going to prove it in practice at a scale facility. So that's really important to be able to do that. And we'll say a bit more about that a little later on.
Thank you. So I guess we can say that customers are, happy to have hydrogen, that networks are ready and making everything safe. But if we turn to the production of hydrogen, which is probably the part that I spend most of my time talking to people about and thinking about, and security of supply, because obviously if you're going to commit to blending hydrogen into the gas supply, you need to have security of supply. How and where hydrogen's produced, and if it's going to be green or blue, but also the storage and transportation of it are huge questions for the industry. So I'd be interested to know how you see hydrogen being produced at scale in the UK and when this might happen. Seeing as we've got Tony on screen, maybe you can start us off, Tony.
Yeah, I'm more than happy to provide comment on that. I think my view is initially we're going to see blue hydrogen appear around the industrial clusters. We've got 5 or 6 industrial clusters in the UK all gearing up with blue hydrogen production, but then we've also got green hydrogen production coming along at pace behind it. So I think there's a two-pronged attack here, in the sense of blue focusing on industry first, and that's going to give us scale and probably give us capacity sooner to start putting some of that into the networks. Equally, utilising green hydrogen as it develops over time, probably stimulated by the renewable electricity generation we're going to see far more of, as cited in the 10-point plan, towards the latter end of the decade. So I think the two are going to work in tandem. From a networks point of view, I often use the term that we're colourblind. We actually don't mind what colour it is. We're happy to just move gas from A to B, which is our role. So the boilers in people's homes, it really doesn't matter what colour it is. We've got to just try and stimulate as much hydrogen production in as many locations, and then we start moving it probably initially through a blend, but then build up to the 100%, and that's where the concepts for the hydrogen backbone that we've been talking about at a transmission level come in, and we can start carrying real quantity of hydrogen around the country. And from that, we can then start to deploy into residential heat and so on. So I think that's where I would start it. It's a two-pronged attack, and we need to see that support coming through in the strategy, hopefully in the next few weeks.
Thanks. Mark, in terms of the transportation of hydrogen, is there a lot that you need to do on the distribution network to get hydrogen ready, or is it something that you can just do with the existing network that you have?
A huge percentage of our network will be hydrogen ready. We've been undertaking a replacement of iron and steel mains through the programme of over the last, since 2002, runs to 2032. But what the testing has proved that we can use the existing network to undertake the transportation of hydrogen. So that's a fantastic piece of work. and really lends itself to this phenomenal asset. I mean, just for example, in the area that I'm responsible for, which is Northern Gas, we've got 37,000 kilometres of gas pipe in the ground, which is equivalent to going from Leeds to Sydney and back again. So it just gives you a scale of what we have in the ground. It's there already. It's fit for purpose. There will be, as we go through the testing process, there'll be elements that we will need to replace, but it will be very insignificant compared to, let's say, if we were an all-electric solution, to be able to take the load of that to people's houses. And from our background, the knowledge we would have to replace a huge amount of the electricity infrastructure to be able to do that. So we're in a great position in the UK. And the other exciting thing for me is, I completely agree with what Tony's saying about the migration. We can use constrained electricity to convert into green hydrogen from wind farms. That's when it's not available for use during the night or whatever, and convert that through. We've got the blue hydrogen from the industrial cluster, so we can start blending into the network and using that excess gas, excess hydrogen into the network. But just imagine having a hydrogen backbone throughout the country, through our transportation, both at distribution and transmission levels, for the decarbonisation of industry, decarbonisation potentially of rail, and decarbonisation assisting with the electricity batteries on hydrogen fuel cell vehicles. So the hydrogen network to me is a powerful stimulus to be able to change dramatically what we do in the UK. So I think there's, we're proving it's safe, but why not use this fantastic asset we've got in the UK to the greater good that is probably quite unique in other countries as well, because we have a heating demand in this country that some other countries don't have. So we've got a very unique proposition in the UK, and I really think we should exploit it to the absolute full.
Could you just explain how you blend? I know 20% hydrogen is what is being talked about. I mean, how do you physically add that and stop it becoming, a greater proportion than 20%? How does it work?
I'm not an expert on the technology, so I would basically say there'll be a limiting equipment to prevent you going over that limit of the 20%, which is being proved for the safety case. So it's a piece of technology that, it's again, what's so exciting about it is it's not new technology. This technology has been available for a number of years in terms of how we can do those things. So it really is as simple as that. I make it sound simple, but nobody should have any concern about how that's done. It's just, almost it's like having a tap. Let's think of it as a tap. You open it so far and you've got 20% in. You could open it further and have more or less in. It is as simple as that. And what we proved by the example of Keele University, the campus there, it is perfectly safe. Customers have accepted it. It's working extremely well. Our next stage now is up in Winlayton, which is just to the west of Newcastle, and there'll be 670 homes that we fed with a 20% blend, which is a really exciting proposition for ourselves, and quite a major staging post for us as well.
Carl, maybe I could ask you, if we're talking about blending, and that would represent, a quite quick cutting in emissions from heating, which would obviously be good for government. How does it work with a boiler? If you have a gas boiler, can it cope with 20% hydrogen? Do you need to get a new boiler that can switch between the two? Like, what's the transition like, and how much is it going to cost people?
Well, in terms of the blending, we've through the Keele University study, we've already now confirmed that up to 20% blend, the existing boilers in the field today will cope with that blend of up to 20%. So that's really good news, and therefore, as Mark was just saying, we need to accelerate that and take the gains in terms of carbon reduction from that blending element. Then as you start to go over 20%, various other important factors start to kick in. And I mentioned a couple earlier on. So the way we sense the flame as hydrogen starts to dominate the gas mix, as we ignite the flame and then control it. So those factors start to kick in. And therefore, from our point of view, once you go above 20% blends, you might as well then go to 100% hydrogen to gain the full benefit that you can from from the decarbonisation strategies. But definitely up to 20%, all existing boilers, gas cookers, gas fires can cope with that blending fine. We've proven that so far.
Thanks. Maybe this would be a good time to do a Slido question. Katie, if you've got maybe the second one on the source of hydrogen that will be most likely to play a role in helping us reach net zero, it would be good to see what people think. Okay, hopefully this question should be appearing before you. There we go. How do we know if it's finished? Give it another couple of seconds. I'm reluctant to draw the conclusion because blue keeps creeping up. Well, we can see that more than half of people think that green is going to play the biggest role, which I think from what, I mean, we should probably explain that blue is hydrogen produced from natural gas using carbon capture and storage to make it clean. But I think a lot of people think that blue will be the sort of transition to green, that we can get blue first, and then while the cost of green is coming down, we can use it. But ultimately, green is where we're likely to be headed. Tony, I know that I called upon you before and you mentioned blue. Is that sort of what you think, that it's a transition, or because the UK has so much gas in our electricity mix that there will be a role for blue in, beyond, say, the 2030s?
Yeah, absolutely. I think the blue will provide us with the scale that we're going to need for a period of time, and it's going to take time for green to build up to almost replace it. So I quite often refer to blue as a transitional technology. Now that could mean that it's out there for 50 years, out as far as, say, 2070. And there's nothing wrong with that, provided you've got some negative emissions happening elsewhere. So we've got to remember that blue gives us a capture rate of, say, 92 to 95%. So there is still some emission from a blue. Obviously, the green is the more pure source. The sooner we can get to that, the better. But that is reliant on obviously, as I said earlier, the renewable generation coming online. So having the two and then transition away from blue towards green, I think makes sense. So I think it's interesting that nobody put other there, and I just wonder whether there are some other disruptive technologies that could come through in the timeframes that we're talking as well. So it'd be interesting if that plays out.
Yes, I noticed in the IEA report I mentioned at the start, and also in some of BNEF's research, when they're looking forward to 2050, they leave a little section blank for undiscovered technology, acknowledging that there are things that we don't think of yet that could come forward in quite a big way. Fiona, I wondered if you think that people care what on this kind of source of hydrogen and how it's produced, or whether that's just an issue for industry and politicians, and the public won't really mind how we get the hydrogen.
The public would prefer green hydrogen, But this is primarily because they think that what's the risk of carbon that's been captured and stored of actually leaking. So in terms of coming back to their safety concerns, no safety concerns when it comes to using hydrogen in the home, but there were some questions about, well, how safe is this carbon that's stored then, and what would happen if it were to leak out? So based on those findings, and also findings of a survey we did of people in Yorkshire and the Humber as well, they would prefer the use of green, but based on the qualitative deliberative research, they recognise that that is not possible right now, and so they completely accept that blue is likely to be a transitional period, and they're more than happy with that. They just want us to do something, actually.
So is there a difference, you mentioned the Humber, in those kind of industrial areas? I think the Humber is maybe one of the most, with the highest industrial emissions in the UK. Are attitudes different there than for other people that maybe don't live right beside something that's spewing out emissions?
We were interested in that as well, and were half expecting to see some differences, but actually not really. We were looking at, for that particular study, to see if people accepted the technology and welcomed it as a new opportunity for the region. And they did. There was a little bit of cynicism about how much of this prosperity that is potentially coming to our region due to hydrogen economy, how much of that will actually benefit local people and how much is going to be taken out of our region. But across Yorkshire and the Humber, it was striking how much support there was.
Yeah, I think it's really interesting because often the industry talks about things, and particularly with electric vehicles at the beginning, I heard about them so much in the industry, but then real people knew what they were or thought they were coming, and now that's finally changing and people are kind of embracing it. And I think it's the same with a lot of these other technologies. You need to bring people along with you. Sorry, do you want to say something?
No, just completely agreeing with you. You're absolutely right. There's an astonishing lack of awareness kind of in the industry. We kind of assume everybody knows about this, but it's just not the case at all. But once people recognise why this is a problem and why something has to change, they are really on board with it.
I think that leads us nicely to the hydrogen strategy, which the government's piece of work that is coming in the next couple of months, so they promise us. And I think there's a lot of expectation and hope in the industry that it's going to stimulate a lot of investment in hydrogen, and really we can see some of those numbers that banks and various others have predicted for the huge amount of investment required in hydrogen. And I'd be interested to know from each of you what you think the most important thing that the government could have in that strategy would be to, get the industry going, whether it's a subsidy or a target. But maybe so that we don't colour everyone's views, we could ask the next Slido question, and then we'll hear from the panellists their view. So we should have another question. Giving you some options on what you'd like to see the government's hydrogen strategy include as a priority. It's interesting, the two that I hear most from people are the top two as well, depending on which side of the industry you're coming from. I guess that a ban on gas boilers has been talked about, and I think it's unclear how kind of willing the government is to kind of make a bold deadline for that. And also the subsidy is something that people talk about as really important. So we can see those are kind of equal in what people would like to see, but maybe we can hear in a bit more detail from the panel what they think the most important things for the government to address are. Maybe Carl, would you like to kick us off?
Yeah, sure. And obviously you can probably guess that the hydrogen ready boiler concept is something that we've been both promoting to government and from my perspective is an important element of the strategy moving forward. And what we've been promoting to the government is that's a no regrets option for them to mandate hydrogen ready boilers from a given date, and the date we're talking about at the moment is 2025 onwards, because then what that enables you to do is pre-populate the park of boilers in UK households with technology that is ready to switch over to hydrogen once that decision is taken and hydrogen becomes more and more readily available around the country. And the other question we get asked associated with that is, so what if hydrogen doesn't come to a particular village or town or city? Then those appliances will perfectly run on natural gas for the time being, and blends of up to 20% of hydrogen in the natural gas supply. And it may be that some of those hydrogen boilers actually never in their working life actually run on 100% hydrogen. Hence, we see it's a no regrets option, really. Let's prepare each household for that switchover, and when the switchover comes, it reduces the intensity of activity on that switchover right down to changing a hydrogen ready boiler over to fire on 100% hydrogen would be about a 30-minute process, that's all.
And I know that we could probably, I've seen panels that spend the entire time talking about cost of heat pumps versus hydrogen boilers, but maybe you could give us a quick idea of the cost comparison between hydrogen and gas, and whether it is going to cost more to do as you say and sort of begin to get hydrogen boilers rolled out as people go on to buy their next system.
Actually, this has been a pleasurable workshop for me, because that's normally the first question I get asked. So it's only the third question today, so that's a pleasant change. So our answer to that question, I already hinted at it earlier on. So about 90% of the boiler is the same, whether it's a natural gas boiler, hydrogen ready boiler, 100% hydrogen boiler. So obviously it then comes down from our perspective to a volume game. If we're producing 400,000 natural gas boilers and 50,000 hydrogen boilers, then the hydrogen boilers will be slightly more expensive. But we're talking within the range of 10 to 15%. But if we get that decision taken and we switch over our whole supply and production to 100% hydrogen, we expect that the cost of producing a hydrogen ready boiler versus a natural gas boiler will become the same within a very short space of time, within 12 months to 24 months.
Okay, thank you. Mark, if we could turn to you next, what would you most like to see in the hydrogen strategy?
I'm not going to repeat what Carl said, but I think in terms of what Carl's message there goes back to the earlier point. I think even that mandation of the hydrogen boilers sets the customer debate. So I think that is a really important cornerstone for moving to a hydrogen economy. And I would agree with the audience there on the top one again. The production needs to be there, so the incentives need to be there for the production of hydrogen in whatever form it is, be it green or blue. And really building on what we've seen on the 10-point plan, of moving from a hydrogen village to a hydrogen town, but really getting some certainty, talking from an investor point of view, we need some certainty about where that targeted investment needs to go. So I think the clearer the policy is, the better. And then we can outline the future. So I think you've got a customer piece with the hydrogen ready boilers. There's going to be incentives required to make those changes. But this is huge, isn't it? You know, this is not minuscule. This is an absolutely huge change for across the population and industry. And I keep likening it back to almost the motor industry. I saw a fantastic program last week in the development from the petrol engine, initial petrol engine, and even you think of the petrol engines at the moment, vehicles at the moment moving from hybrids now to all electric, from diesel. The transition, but it needs to be mandated. It needs to have those clear policy decisions on how you're going to achieve that. So seeing some real positive policy decisions that people are investable, and also getting customers engaged with the hydrogen ready boilers, I think are two key elements to this.
Thank you. And Fiona, do you have any ideas for anyone from Bays who's on listening for how they can, bring the public along with this and make them excited through what, the decisions they're going to make in this strategy?
I think simply making people more aware of what happens when they use gas in their homes at the moment will make them excited. So definitely hydrogen ready boilers, it's such an easy win. So people's big concerns about hydrogen conversion is the cost of a boiler. So if we can take that out of the equation by having people replace their boilers earlier on with a hydrogen ready one, that would be great. But also in terms of wider behaviour change, if people have got an appliance in their homes that's clearly better for the environment, it can do a tremendous amount of changing all the psychological predictors of behaviour that will encourage them to take on a wider range of environmentally and sustainable behaviours.
Thanks. And Tony, do you think that the UK has a chance to put itself, up with Germany and make this strategy really world leading in terms of our ambition for what we want to achieve in hydrogen?
Yeah, I absolutely do, and I think that the fact that we're taking a little longer to really determine what it starts to look like really gives us a real good chance of doing that. So coming out with a strategy that actually reflects the end-to-end requirements, and it's no surprise that we've got people that view production as essential and others viewing the use, as in the mandate for hydrogen-ready boilers, is essential. I'd emphasise that we actually need that end-to-end piece, as well as the networks in the middle that join the production to the use. So making sure that that strategy delivers on all of those points, we've got the right incentives in each area, because this will only work if the whole system moves forward overall, rather than one the upstream or the downstream working individually. So it needs that central coordination, such that we then as networks can start joining those dots, build the backbone, get the blending going. So there's a number of touch points which will allow us to get there. So I'm hoping we'll see that clarity start to come through, and it allows the investment to flow, the regulations and all of the legislation that we need to achieve the targets and the opportunity that we've got. And if we can do that, it really leverages then into actually how do we take this abroad, actually use our knowledge and export it as well. So it's a superb opportunity for the UK to grow further overseas with the technology we're developing as well.
Thank you. Yeah, there's a huge amount of interest in this sector, especially given that not that much has happened yet. It's all sort of projections, so it will be fascinating to see how the government sets out the plan. And yeah, I think there's a lot of investment ready as soon as we get clarity on what the framework's going to look like. So yeah, hopefully we'll see that in a few weeks. I think that takes us to the end of our time. So thank you to the panelists for joining us and for giving us your views. It was really interesting. And thanks to everyone for joining us. Hope you found it an interesting discussion and that you'll stay on for some of the presentations. And I will hand back to Chris, who will take it from here.
Lovely. Thank you very much, Rachel, and thank you very much, Mark, Fiona, Carl, and Tony. A very interesting conversation to kick us off, and that draws us to the end of the first stage of today's events. The second stage, we're now going to move on to the presentation section, and it's the opportunity to hear firsthand from the and question the teams working on the projects. And the group chat is open, so do post questions there, and we'll pick them out and put them to the presenter at the end of each presentation, and hopefully we'll have time to do that. But as I say, if there are any questions that are left unanswered, we will follow up with those. And so if I can just remind people to keep yourselves on mute, and unless you're the presenter, keep your cameras off to preserve broadband. So without further ado, we'll now move over to the National Grid team to talk about the Future Grid projects. Thank you.
Thanks, Chris, and thanks to all the presenters. Really interesting discussion just then. So I'm going to talk a bit about the sort of wider context of gas transmission within the UK, and how we're considering operating with hydrogen, and my colleague Sean will then come on and talk in a bit more detail about the Future Grid project, which is the main project that we've embarked on to assess the compatibility of the transmission system to transport hydrogen. So if you could just go on to the next slide, please, Katie. So just a bit of context. So the national transmission system in the UK there's only one in the UK. There's a number in some European countries, but the national transmission system is worth around £6.3 billion. So it's a hugely valuable embedded asset that's already there in the ground in the UK. We've got around 7,500 kilometres of high pressure pipelines which operate in the region of 70 to 100 bar. And the system transports over 800 terawatt hours of energy each year, which is, sort of for reference, around sort of 2.5 to 3 times as much as the electricity system. And so our main goal is to leverage this hugely valuable asset and use it to help transition the UK towards hydrogen in a big way. So a bit of the work that we've been doing. So we've been doing a lot of industry collaboration within the UK. So Gas Goes Green is one of those initiatives, and we've been working with the distribution networks and collaborating with them, and in a joint working group with the Department for Business, Energy and Industrial Strategy, because there's a huge amount of knowledge being generated from all these research projects. So we're aiming to pool the knowledge wherever we can, learn from each other, and use that knowledge to make a case showing that we can operate the networks safely with hydrogen in the future. We've also been looking more widely into Europe and collaborating with some of the transmission system operators there. So there's a few names. One of our key partners is Fluxys, who are the Belgian transmission system operator, and they're doing a lot of materials research, and we're hoping to share our understanding from Future Grid, and we've got a strong partnership there. And then that is sort of developed into looking at a European hydrogen backbone, which I'll talk in a little bit more detail about a bit later on. So next slide, please, Katie. So as I said, we've got this embedded network in the UK. And it'd be nice if we could flick a switch and transition it all to hydrogen in one go, but unfortunately that's not really practical. So we've got to think about, how do we actually manage that transition? Where do we start? And to that end, we have started what we call Project Union, which is looking at how do we link up some of the key industrial clusters in the UK and sort of leverage their own net zero ambitions and all the industrial expertise they have, and the ambition around carbon capture. How can we link those up and form a sort of hydrogen backbone for the UK, and then we can use that to sort of springboard and then spread that hydrogen penetration out into the rest of the network. And so this project is essentially assessing the capability of those pipelines, those assets, and how we can use those going forward. Next one, please, Katie. So on the European hydrogen backbone, this has been a very big project looking at the whole of Western Europe. Because Brexit or no, we are still quite closely tied into the European energy market. We've got interconnector that transports gas across the channel, and so it's important for us to stay connected to these operators. So this project was looking at how do we use the existing transmission system and perhaps create new pipelines where necessary to create a hydrogen backbone for Europe as a whole. So it's looking at a pipeline network of almost 40,000 kilometers by 2040, the majority of which, around 2/3, would be conversion of the existing pipelines, with an additional 31% of the network being made up of new pipelines. And as you can see, the estimated cost is in the region of sort of 40 to 80 billion euros. Next one, please. So just thinking about some of the challenges we have looking at the existing asset base, whilst hydrogen is very similar in many ways, it's a colourless, odourless, flammable gas. There are some key differences which introduce some challenges when transporting it through a high pressure transmission system. So one of the first ones we looked at was material compatibility, and whether the hydrogen impact on our steels is going to be a serious issue. So we assessed this in collaboration with the health and safety executive, and it's still a concern, but our initial concerns that it would be it would write off the transmission system were sort of unfounded, and it's that there aren't any key blockers. So we're going to keep doing materials research going forward, but it's looking promising that the network will be compatible. We have to build up our evidence base, because a lot of the risk management on the network at the moment is made up of decades of experience within sort of oil and gas networks, and all of the safety records that have come from operating these systems for many years. So we need to build up an evidence base which is going to allow us to get to a similar level of confidence with our assets. We have to look at asset compatibility, because as I mentioned, hydrogen has some different properties, which mean some of the key assets that are on the network, things like regulators, valves, etc., may not perform in a similar way with hydrogen as they do with natural gas, and that's one of the key focuses of future grids, which you'll hear about in a moment. We've also got to think about sort of network management. So one of the key drivers within transmission is security of supply. So we need to make sure we can continue to maintain security of supply even on the coldest winter's day with hydrogen, as we have done with natural gas for decades. And so how are we addressing some of these? So we're doing a huge amount of asset testing through the Future Grid project. We're looking at bringing in data information from wherever we can, collaborating with all sorts of different networks, research organisations from not just the UK and Europe, but from all around the world. We've had talks with those in Australia and the US, Hong Kong, and then doing network modelling to understand, so once we transition this network to hydrogen, what does operating that network look like, and how does that differ to how we operate today? Next slide, please, Katie. So in terms of increasing our asset knowledge, there's sort of a rough roadmap here. So we've already been doing some internal research that I've mentioned. We've done external research collaborating with a European TSO. So there's Marcogas, which is a trade organisation. They have produced some information around asset compatibility, which you can see there. We've been engaging with OEMs and our suppliers to understand what knowledge they have on compatibility of their assets for hydrogen. We've got the H2GAR, which is a working group with 6 different work streams with all the European transmission system operators to share knowledge. Again, targeting RFIs for specific vendors, valve manufacturers, etc., to get as much, just bring in as much knowledge as we can. Next one, please, Katie. So that's sort of the high level, looking at the transmission system and what it means, what hydrogen means for that. I will now pass you on to Sean, who will talk a little bit more in detail about the Future Grid programme and what we're doing there.
Thank you, Lloyd. Yep, and this is where the Future Grid programme comes in. So Future Grid will build a hydrogen test facility to demonstrate that the national transmission system can transport hydrogen and to showcase the capability of our assets to do so. This will help develop the gap in our knowledge that Lloyd was just talking about a moment ago. Next slide, please, Katie. If you could just do the next animation as well, please. Thank you. This ambitious programme seeks to build a hydrogen test facility and will be using decommissioned assets and putting them all together at DNV's Spade Adam facility, where extensive pipeline research has been carried out over the last 40 years, and it's a world-class facility for carrying out this kind of research. The Future Grid test facility will connect to the H21 distribution facility, creating a representative UK hydrogen testing and training facility. And as you can see on the slide, there's some key statistics regarding, about the project. Key to the Future Grid project is working collaboratively with our project partners, who I'll give you a bit of an overview about now. So, as I mentioned, DNV are our main partner, who are responsible for building the test facility and developing the comprehensive master test plan, which we're using to test across the range of decommissioned assets that we will be repurposing at Future Grid. We are also working with the HSE Science Division, who are supporting the development of the test facility and will also be providing independent technical assistance and validation across the project. Obviously, we're working with Northern Gas Networks, who we are collaborating with to drive closer links with the H21 project, which is already built a distribution test facility at Spade Adam. As Lloyd mentioned earlier, we're working with Fluxus on the project, who are the Belgian gas transmission operator, and they are contributing a substantial level of hydrogen research. And with this, we're ensuring we've got an international collaboration on this project because it is world leading. We're also working with Durham University, who are focusing on development skills and training courses associated with hydrogen competencies, and Edinburgh University as well, who are supporting trials and providing technical papers, and they're also providing links due to work they're doing on existing hydrogen projects with some of the gas distribution networks. Next slide, please. So as you can see on this slide, this is the Spade Adam facility where we will be building the Future Grid test facility. In the middle of the photo, you'll be able to see the high street terraced houses, which are soon becoming, some of the most famous houses in our industry. Where mentioned earlier, there's a lot of testing of domestic appliances and boilers with hydrogen being carried out at these houses. Just next to the high street is where NGN's constructed the H21 distribution facility. And then towards the top of the photo, that is where the Future Grid test facility will be built. And this will be connected to the H21 facility, creating with H21 and the high street effectively a beach to burner model for modelling the hydrogen network. Next slide, please. Future Grid will be built with existing national transmission system assets, which are being decommissioned and repurposed from across the country. And this is to ensure we're providing a representative of the national transmission system. So we're not looking to use new assets. We want to use our existing assets because we're seeking to transition and convert our existing network to use hydrogen. In addition to this is also making sure that Future Grid as a project is as efficient as possible. All the assets that we're using are due to be decommissioned as part of planned project work or have already been decommissioned. And if you could just skip through a couple of the animations, please, Katie. We will be modelling various different parts of the national transmission system with the Future Grid facility, including an entry point, so where the gas comes in at a terminal, a block valve facility, which is where we would carry out an isolation of the pipeline when required. We'll be testing pipeline assets, so trying to gain an understanding of what impact hydrogen has upon our pipe materials, and more importantly, what sort of interaction it has with the wells, which is a key asset on our system. And we will also be modelling exit points, which will provide a model of how our customers and distribution networks receive gas from the national transmission system. Basically, all the decommissioned assets that we're getting from across the national transmission system are all going to be transported to Spade Adam, where they'll be rebuilt and joined together with a couple of connecting pipes and joints, etc., effectively like a giant Meccano set. Next slide, please. So Future Grid will test the national transmission systems at 3 different concentrations. Firstly, we will test a 2% hydrogen in natural gas concentration, and the reason for this is 2% is the amount of hydrogen in natural gas at which we believe it starts to have some sort of different interaction with our national transmission system materials, and effects such as the permeation of hydrogen start to come into play. Next, we'll be testing at 20% hydrogen in natural gas blend, which is the level as sort of discussed earlier on today, at which we believe current domestic appliances and boilers can operate without any major needs for changes to be carried out. And finally, we'll be testing at 100% hydrogen, which is the amount of hydrogen we need to ensure we meet our net zero goal. If you could skip, thank you. Throughout these 3 different concentrations of hydrogen, we will be operating the Future Grid facility for between 6 to 12 months across these different concentrations, following a detailed master test plan, which has specific tests to test the functionality and integrity of the various assets that are forming part of the Future Grid site. We will then review and evaluate the test results, and also use some research from our project partner Fluxys and extrapolate some of this data, so we've effectively got results across the national transmission system. Then working with our operational engineers from the control room, so the people who make sure gas gets moved around to the right part of the country as part of their day job, they will help us to validate the flow parameters from on our hydrogen model, and look at key areas such as gas velocities, pressures, energy delivery that we need to consider for a future conversion to hydrogen. Next slide, please. The testing and research being carried out as part of the first phase of the Future Grid project will help develop and further mature national grids and general industry knowledge as well, in terms of what we need to do to ensure a safe and resilient hydrogen network in the future. So there's 3 key areas that we will be further informing as part of this research work. If we could skip a couple of animations, please. Firstly, we will have a look at the hazard assessment of a transmission system and consider it based on a network transporting hydrogen instead of natural gas, and try and understand what sort of impact that has on the societal risk of our pipelines. Next, it will also consider the quantitative risk assessment, and if we need to make any sort of deviations for our assets being used to transport hydrogen instead of natural gas. Finally, we'll also consider, do we need to make any sort of adaptation or make any changes to our overpressure risk methodology, which is important for risk analysis and emergency planning. These 3 key areas will then all feed into National Grid's safety case, which encompasses our policies, procedures and work instructions, and identify an overall understanding of what the impact of operating with hydrogen would be upon our network. Next slide, please. So far today, I've talked you through phase 1 of Future Grid, which is to demonstrate that national transmission system can transport hydrogen and also showcase the capability of some of our assets. Obviously, this is just the first phase of a wider programme. The intention is for this programme and the Future Grid site at Spade Adam to continue to increase in scale and ambition as we progress. Phase 2, we will be looking at installing more complicated technology such as compressors, which are critical for the operation of the national transmission system, as well as considering trial and deblending technologies as well, which will also be very, very critical in terms of how we would convert to either a blended hydrogen network or a 100% hydrogen network. Finally, in phase 3 of the Future Grid programme, we will work with third parties to test new technology at the site as well, and work closely with suppliers to try and develop new solutions, new assets. And this also sort of feeds back into what Lloyd was discussing earlier on in the presentation. As part of the Future Grid programme, we will be reviewing our assets and testing our assets to try and get some data about how they operate with hydrogen. We will then use that data to build a more informed model of the national transmission system to try and understand what the impact would be of operating hydrogen would be, and also understand what further work streams and what further research would need to be carried out to help us get to what ultimately our goal is of net zero. Then, it'll feed a bit further into this transition to looking at building a hydrogen backbone and linking the various industrial clusters. And, finally, most importantly, it all comes back to collaboration as well with wider industry groups, customers, key stakeholders as well, and to, all work together on this journey to net zero, which is where we need to get to. And that's everything. Thank you.
Lovely. Thank you very much, Sean, and thank you very much, Lloyd. I think it's interesting. So one of the early questions in the chat box was around compression and compressors. And to some extent, you might have covered this in one of your later slides, Sean. But the concern raised was, aren't there bigger issues around repurposing compression than there are around repurposing the pipes?
I can pick up if you like, Sean. So yeah, it depends. So there's the sort of issues with compressors are twofold, because you've got the gas supply to actually drive the engine. So a lot of our engines are gas generators for the turbines, and you've got to think about the fuel supply there. But luckily, there's a lot of work that's going on within turbine manufacturers, such as Siemens, who obviously see hydrogen as a large market. So they've actually produced a graphic showing the compatibility of their existing fleet, and there are a number of their existing units which are already compatible with hydrogen, some of the newer ones, and many of them are compatible with hydrogen blends. We do have a sort of asset replacement program for the compressors, so it's a sort of similar issue to the boilers in terms of we need to make sure what we're replacing now is going to be ready for the future. And then the other side is the actual compression. So hydrogen does have different compression characteristics to natural gas, which make things a bit more difficult. So the general view we have at the moment from initial research we've done is that it will require significantly more energy to compress hydrogen than natural gas. However, hydrogen loses a lot less pressure as it transitions down the network. So we can have a number of compressor sites with bigger units but further apart, essentially. So that's the sort of initial view on compression.
Thank you very much for that one, Lloyd. And unfortunately, we're out of time at this point, but don't go away. I'm sure hopefully there'll be time to catch up with questions. So we'll now move on to Damien Hawke, who's going to talk about blending onto the grid. Damien.
Chris, it's Tony Balance here. So Damien unfortunately can't be with us today, so I'm going to kick this off, and then a couple of my colleagues, James Whitmore from Cadent, then Tom Isaac from Progressive Energy, will take us through the detail around blending and in particular kind of the technical and safety cases. So if we go on to the next slide, I'm going to really just set the scene by talking about why blending is so important. I think the starting point for me is, you know, and this was covered in kind of some of the voting, the need to create a demand for the production of hydrogen is really, really important. And that's where blending can really play an important role by supporting heavy industry in creating that demand source such that we can take hydrogen at scale into our networks. It's already been covered in some of the discussion about the customer impact, but the blending of hydrogen into the network is going to be non-disruptive, low cost and early adoption for customers. So, you know, the others will cover this off, but, you know, we found from our Kiel trial that there really is no disruption to customers when you blend hydrogen into their traditional natural gas supply. So in some sense, it ticks a box there. It can also be a meaningful decarbonisation opportunity in its own right. You know, we calculate that could be 30 terawatt hours per annum in the UK if you blended it ubiquitously across the piece, and that's equivalent to taking 2.5 million cars off the road. Again, this was covered earlier, but you know, the support that, you know, getting a hydrogen economy up and running, that will provide to the supply chain, to other industries, shouldn't be underestimated. And next, you know, addressing some of those customers' perceptions. It was interesting to note that actually there isn't that perhaps negative perception that we might think there would be, but nevertheless, you know, if we can start to use hydrogen, any fears that are there can be alleviated through the fact that customers ultimately get used to it. And then lastly, it can unlock the use of hydrogen more widely, particularly in transport is the obvious place. And Chris, you mentioned that earlier, as others have, in terms of, you know, where hydrogen can be used for, you know, in cars or rail or wherever else, you know, and we could obviously get, you know, hydrogen refueling facilities as part of it. And I think that the last thing before I hand over is, you know, it's that pathway to, you know, 100% hydrogen down the track. You know, if we can start to get it used and get it accepted, then it is the pathway to the future. So at that point, I'll hand on to James, who will go through a bit more of the detail on HyDeploy.
Hi, yes. Good morning, everybody. So I'm James Whitmore, HyDeploy Programme Manager for Cadent. So what's really important to note, in addition to Tony's slide there, is that the UK government have now ratified how important hydrogen blending is as a key step to decarbonising the gas grid. So both the 10-point plan and the Energy White Paper have explicitly called out hydrogen blending as a policy objective, and that's to have the ability to blend hydrogen into the gas grid by 2023. And the HyDeploy programme is front and centre to this policy objective, being the only technical programme in the UK exploring the end-to-end use of hydrogen blending across the distribution networks. And it's the success of the HyDeploy programme to date that has provided the government with confidence that hydrogen blending can be achieved within these timelines. Next slide, please, Katie. So the HyDeploy programme is being led by a consortium of partners. So we've got Cadent collaborating with Northern Gas Networks, who you'll hear from later today, and also Progressive Energy and others. And Tommy will also, from Progressive, do a piece later today. And the objective of the programme is clear, and it's to establish that a blend of hydrogen and natural gas can be distributed and utilised safely and efficiently across the UK gas distribution networks without changes to consumers, disruptive changes to consumers. And that's highlighting the point that Tony just made around the success of the Keele University trial, not impacting domestic users that were involved in that trial. Next slide, please, Katie. Great. So how are we going about this? So we have a phased program to prove that hydrogen can be blended safely into the networks. The first stage was at Keele University. So we've just successfully blended hydrogen into Keele's privately owned network, and that was to circa 100 domestic homes and 30 faculty buildings. The evidence created to allow us to do this resulted in the UK's first HSE approved hydrogen safety case for domestic use. And a key success was not only the technical and engineering feats, but also the fact that consumers that were part of this trial have expressed no change in the way that they cooked or heated their homes. Now, the second phase builds on the evidence created at Keele, and we take that to the first public gas network at a town called Winlayton in Northern Gas Networks region. And this network will consist of 668 homes and will have a diversity of users, appliances, installations and materials. And then following this, we then plan to focus our attention on the wider evidence that's required for hydrogen blending across the UK. So this will expand the evidence base to look at industrial and commercial users, higher pressure tiers, and ultimately unlock the safety case for hydrogen blending across the gas distribution networks by 2023. There's a point to note that the final phase, we're in discussions with Ofgem about how to finalise our plans to reach that achievement, but that's our plans in line with government policy. Next slide, please, Katie. Thank you. So just one point to make around the regulatory position. So currently, for those that aren't aware, the gas safety management regs only permit 0.1% of hydrogen in the gas stream. Now, to legally exceed this, the Health and Safety Executive must grant an exemption to the regulations. And therefore, a safety case is required to demonstrate that a hydrogen blend is safe as natural gas to use and consumers aren't at risk. So I'll now pass over to Tommy, who will talk us through how we go about creating the evidence to build the safety case. Thank you.
Thanks, James. I assume you can all hear me, but please shout if you can't. So the next couple of slides, I'm going to outline the structure of the safety case that was developed, one to support the Keele safety case exemption, but also to support the Winlayton exemption to GSMR, and will ultimately be the structure of safety case that will be presented to support the wider rollout. So this slide tries to summarise what is sort of multi-million-pound programme over many years in one slide. In effect, the safety case rests upon four key areas. You have the research associated with appliances and for both their short-term and long-term safety and performance. There is the research associated with materials and assets. So this is looking at end-to-end from the point of injection through to the point of use to make sure that they are compatible with hydrogen blend. Then there is the more fundamental gas characteristics research, which is to understand how the underlying physics of a hydrogen blend differ to natural gas. And then that supports the final stage, which is the procedures and gas detection, which is largely where all of that research comes together and forms very practical outputs. Now, all of those individual pieces of evidence in themselves don't demonstrate parity of safety. What's required to contextualize all of that information is a holistic risk model. So to support the actual safety case itself and the demonstration of an as safe as gas, what we've developed is a QRA, which models the risk profile of the gas network. And we've baselined that in public results or public data that is available today, so we can validate the kind of causal chains of risk. And then second to the GB validation is to create a regional risk model of the site that we're looking to blend into to understand what the individual risk is of that region. And the final step is to crystallize all of the evidence into single numbers effectively that go into the risk model as base events that then represent the gas qualities associated with a blend, and then that percolates up to the top, which then allows a direct numerical comparison to be made of the risk profile of natural gas versus a blend, which then allows a case to be made and then presented to the HSE that the change being proposed is as safe as the base case. What I'm going to do now in the next couple of slides is just go into a bit more detail on the key technical areas and just draw out some of the key results from those areas. So the first one is appliances. Appliances has really been the kind of foundational rock, if you like, of the safety case, because this is the sharp end of risk. So the current risk profile today within the gas network, or from our use of gas, should I say, is that about 80% of the individual risk of use of gas is associated with appliances. It's basically associated with CO poisoning, and then the remaining 20% is associated with fire and explosion from leakage. So understanding how a blend might impact the safety profile of appliance performance is absolutely critical. So in the top right, I've just got a couple of standout photos just to demonstrate that actually from a visibility perspective, the flames really don't look any different. I'm sure I could have flipped the naming of the images, and people would have probably would have believed it as well. So normally we run this test at conferences, and people can't normally tell the difference between the two flames. And clearly the one on the right has nearly 30% hydrogen. So the appliance work within the HyDeploy and HyDeploy 2 program has created a generic evidence base for all domestic appliances within the UK dating back to 1976, which is when the first natural gas standards came into force following the conversion from town gas. So what we've got is in effect a complete evidence base for domestic appliances that demonstrate there are no safety or performance issues associated with the introduction of a blend. And on top of demonstrating that there are no issues, there is actually a drastic benefit that can be drawn from the introduction of a blend. So this is shown in the graph on the left-hand side. This is a key test that we performed where we took some adjustable boilers where you can change the air-fuel ratio, and then we pulled back the air to try and promote the production of CO, which is effectively to simulate faults within the appliance or within the airstream up to the appliance that generates CO. And as you can see that we managed to generate up to 40,000 ppm CO, which is an incredibly dangerous situation to be in. So we managed to map effectively all of the fault conditions that a appliance could see. And then on the y-axis is the reduction in CO production that was produced following the switch to a hydrogen blend. And as you can see, that we were achieving around an 80 to 90% reduction in the production of CO. So you can imagine that then flows into a very significant reduction in the CO risk associated with faulty appliances. If we go on to the next slide, please. So here's nice images of our material testing program. The process that we went through to assess materials was to do a very comprehensive asset survey. So for the keel safety case, this consisted of identifying around 2,000 assets, where we broke them down into their subcomponents and then their individual materials of construction. We then developed an experimental program to then soak them in a hydrogen gas and then test their mechanical properties. So we decided to use experimental conditions far above what we would see in the field trials. So we were testing samples at 8 bar pure hydrogen relative to the 20% that would be used during the trials. following this saturation process, we then mechanically tested them and then inspected the surface of the fracture to see if there was any evidence of hydrogen permeation and any detrimental impact upon the materials. And broadly speaking, what we found is that across all the materials tested, that there was no meaningful change in the mechanical properties of the materials, which gave a very solid basis of evidence to demonstrate that the assets that would be exposed to the hydrogen blend would be capable and suitable of being exposed to them. Go forward to the next slide. And this is a couple of images from our gas characteristics program. The first two on the left is our leakage assessment, and then the right is our consequences assessment. So clearly leakage, ignition, and consequences are a key element of understanding risk. The way in which gas leaks in the real world is far more complex than a short analysis would imply. You have lots of competing factors, and trying to understand what the net effect is of leakage requires actually some dedicated experimentation and some quite complex simulation. So that's exactly what we did. We used this facility on the left-hand side at HSL in Buxton, which is a controlled wind tunnel, effectively, where you have a box inside a box, and in the smaller box we can release leaks in proportion to the size of the box, where it's a room, and at different gas pressures and across different leak holes. And then we can control the wind that goes over the box, so we can control the external wind conditions. We undertook a series of tests, and then we simulated all of them using a CFD model that we created of the facility, which is the middle picture. And then we created a simplified model that then was validated against both the experimentation and the CFD, that then allowed us to undertake Monte Carlo analysis on that simplified model to put all of the real world variability that you would see in wind conditions, leak sizes, etc., to understand what the overall effect of the blend would be on leakage characteristics. And what we found was that there was no change in the gas cloud concentration or the gas cloud size that resulted from leakage. And what this effectively boils down to is that the driving force for a potential increase in volumetric leakage rate as in the turbulent flow regime is the same phenomena that drives ventilation when you have a leak. Both are being driven by the buoyancy of the gas. So the escaping gas out of a room draws in air, and then that's what creates the stable dynamic between air and the leaking gas to produce your cloud. So in effect, what you've got is a self-correcting mechanism where any reductions in buoyancy that might promote leakage rates actually promote ventilation as well. So one over the other produces a net effect of nothing, effectively. And that's been experimentally, that's been analytically predicted and experimentally proven. When it comes to the consequences side, this is where we've probably done the most work. So we constructed a facility on the right, which is a repurposed steel container ship, where we created a room or a two-room setup and had lots of instrumentation such as pressure monitoring and temperature monitoring that then allowed us to create flammable environments within the room, ignite them, and then study the explosion characteristics. So all of this phenomena takes place within about half a second. So you have to have incredibly finely tuned instrumentation to be able to get data to be able to actually assess these things. Now, the explosion characteristics, as we predicted, are incredibly complex because you have lots of different factors that go into how explosions actually manifest and the overall impulse and overpressure that results from explosions. And most critically, it is a combination of the stoichiometric ratio, so effectively the gas-air ratio, and any disturbances within the local geometry that then promote turbulence. What we found is that the real-world results align fairly well with analytical predictions from models, where you find a slight increase in overpressure as a consequence of the increase in the laminar burning velocity, but you find effectively no change in the impulse, which is the pressure time curve. And so that's what the building effectively would feel. So it's not just a function of what's the overpressure, it's also how long would that pressure wave sit on the wall to be able to cause any structural damage, and that's measured through the impulse, which broadly stays the same between the two gases. There's clearly lots of other work that we can go into, but there are a couple of highlights. If we go on to the next slide. So this is just to draw out one of the key outputs from the programme to date. This summarises a huge body of work where we assessed all of the downstream procedures, both domestic and commercial, for BSI and IGEM standards that underpin the gas-safe competencies that an engineer would achieve through their ACS training. We reviewed every procedure with a third-party procedural expert through Blue Flame, and we went through a process of technical question generation, answer, and to try and understand how the procedures might be impacted by the presence of a blend. And where we ultimately landed to was that there was no change required to any downstream domestic procedure to accommodate a blend. That conclusion and the supporting evidence was then presented both to IGEM and to BSI through the relevant committees, and they agreed with our conclusion, and that ultimately turned into a gas safe bulletin that was issued this year, that was jointly authored between IGEM, BSI and HHIC to confirm that there was no changes required to the current procedures of natural gas following the introduction of a blend. And that's clearly a major hurdle to get over, because we've got something like 130,000 gas safe engineers across the UK, spread from conglomerates like British Gas all the way through to one-man bands. So organising a wholesale retraining of that workforce would be quite an undertaking. If we go on to the next slide. So this is a state of play of where we think the evidence is for blending. You've effectively got a number of evidence areas that need to be covered, and then the depth at which we believe they are covered, from initial exploration to a controlled trial like Kiel or Forman-Leighton, to being able to facilitate unbounded deployment. We feel that the HyDeploy programme currently has got an evidence base that would support unbounded deployment for domestic installations, low pressure and medium pressure procedures and downstream procedures. And there is sufficient evidence to support controlled trials for materials and assets as well as gas detection. Where we haven't really touched upon to date is industrial and commercial and IP and HP procedures. Now, the lighter blue boxes is really where our focus is going to be going forward for the next 2 years, which will see us through to the end of the programme, particularly the industrial and commercial work stream, where we've got a quite large 6-work package programme that we're trying to work through to try and bring the industrial and commercial evidence to the same standard that we have domestic evidence. And then the idea is by the end of the HyDeploy 2 programme, we'd have brought all of those outstanding evidence bases down to the point where we've got a fully generic, unbounded evidence base that can be reviewed to support national blending. And that's the end of my slides.
Lovely. Thank you very much, Tommy, James and Tony. You've actually answered the last question on the slide there, really, Tommy, which I think is quite helpful given where we are on time. And the question was around the body of evidence on blending for I&C and generators, and you covered that quite nicely in your last slide there as we move forward. So I'd like to welcome Tim Harwood, who's the H21 Program Director at Northern Gas Networks, and Tim is going to cover going beyond 20% hydrogen. Tim.
Thanks, Chris, and good morning, everyone. I hope you're all enjoying the presentations and the panel discussion so far. So yeah, I'm Tim Harwood. I'm the H21 Project Director, and I'm going to spend the next few minutes telling you about the Phase 1 work that we've been doing as part of the H21 programme, and some of the conclusions that we've drawn out from the end of that report. So if you could just flick on to the next slide, please. Okay. So yeah, H21 is an Ofgem funded collaboration project. It does involve all the UK gas networks as partners. You can see there from the map of the UK where all the sort of gas distribution companies fit in, and that's where Northern Gas is in the north of England. So if you want to flick on, please. So yeah, I'm really proud to be part of the H21 programme. We've been going for about 4 years now, and they've done really good in-depth research into the safety case for 100% hydrogen, try and demonstrate that we can operate gas distribution networks on 100%. And the research is going really well on a number of different fronts, which I'm sort of going to come on and talk to over the next coming slides. So yeah, thanks, Kate. Could you flick on to the next slide for us, please? Thanks. Yeah, the testing is really, in Phase 1, has been in 2 different areas. One is the HSE's Science Division at Buxton in Derbyshire, where we did a lot of leakage testing. What we did is we removed hundreds and hundreds of assets from the gas distribution network, which were being removed as part of the iron mains replacement programme. So for those of you that don't know, we've got a 30-year programme to replace iron mains within 30 metres of property with the yellow plastic pipes. And we took advantage of those assets being removed to take them out safely and transport them to the HSE's lab in Buxton, where you can see in the photograph there that we set up a testing rig. And what we did is we tested them on natural gas, and then we tested them on hydrogen to compare leakage to see if any assets leaked on hydrogen that didn't leak on natural gas, and were the leakage rates any different. The great news from that research is we didn't find any assets that leaked on hydrogen that didn't leak on natural gas. So that was really good news. We also calculated the leakage rates for natural gas versus hydrogen, and again, the actual rates recorded from the assets that we were testing were in line with the predictions and the modelling that was done by the scientists at the HSE. So again, really good news. Nothing there that sort of caused us any concern. Nothing that we didn't expect to see, which was really good. The other phase of the testing was at our Spade Adam site, and obviously a number of presentations this morning have talked about sort of what's going on at Spade Adam and the development of the site. So we built this row of houses called the High Street, and did a number of consequence tests, mainly to determine how hydrogen would react escaping from pipes and leaking services outside, like you'd normally get in any town or city in the country. Does it migrate into properties? Does it react differently in different ground conditions compared to that of natural gas? There was hundreds of different experiments done to do with tracking and dispersion and the ignition potential and explosive limits. Again, there was nothing there that we didn't expect to see. We created a number of different ground conditions. So you've got from your tarmac roads to your grass. We even had a sort of a mini allotment. We also looked at migration of hydrogen, things like street furniture, cabinets, lights, starter motors on cars, doorbells, alarms, mobile phones, anything that could create a spark, and just to see what would happen in hydrogen air mixtures against a gas air mixture. And again, the results from that are really positive. There was nothing that we didn't sort of expect to see. And subsequent to a lot of the testing being completed in the high street, we've now introduced 100% hydrogen boilers inside the houses, and we're doing more tests with bays, looking at things that go on inside the home as well. And those assets will continue to be used as we go forward, and they will form part of the phase 2 programme, but also part of the future grid as well with National Grid. So it's all sort of coming together really as a fantastic asset for the gas industry and a great research facility at Spade Adam. Next slide, please, Katie. To offset the research on the safety impacts of hydrogen, it's very, very important that we also look at the social impact of it and the society and the social acceptance. We've done a lot of work with Leeds Beckett University, and Fiona, who was on the panel earlier, is sort of heading that up. We've done lots of different workshops. We've looked at the perception of hydrogen, what people understand about decarbonisation and making the world a sort of safer, greener place to live in. Some of the terminology and how we couch the language when we talk to customers, what they understand and what they don't understand. Really interesting, in-depth research that is actually continuing as part of phase 2 as well. The main findings were that cost and disruption are the big things that customers don't want, which, going back to the conversations earlier about being able to replace a boiler with something that's hydrogen ready, is very, very low cost, low disruption compared to, say, a heat pump or all electrification of homes. So we feel that this is a great counterbalance to all the research and the safety related aspects that we do, and it continues onwards. We're now doing research into how we would talk to customers about converting them over to hydrogen. How would we message it? What sort of communication formats do they like? How should we do it, and what language we should use? So yeah, it's always really good to balance off the sort of safety related aspects of any research with the ongoing social acceptance, which is just as important. At the end of the day, if we prove the safety case for hydrogen, what's really left as a barrier is economics of producing hydrogen at the right price and the social acceptance of hydrogen across the country. So this work is absolutely vital. Next slide, please, Kate. So moving on now to sort of some of the findings from our research and our risk assessments that we do as part of our safety case. We've got a fantastic safety record in the gas industry, something that we're really proud of. We've got a 99.99% reliability and resilience of our network, and you're unlikely to have your gas supply interrupted more than once every 140 years, which is an incredible achievement, really, if you think about it, compared to some other industries. And we want to try and match up to those same high standards when we move over to hydrogen. We've demonstrated over the years that we have got good controls and processes in all our policies and procedures and the way that we run in our safety cases. The safety case for hydrogen is underway. We have discussions with the HSEs. We've been going along. This is the end of phase 1. We're actually partway through phase 2 now, and this time next year, the final report for H21, as far as the safety research will be concerned, will be published. But at this point in time, we're very, very confident that the societal risk of hydrogen can be reduced down to as low, if not lower, than natural gas. If you look at the graph on the left-hand side, it's taken from the Office for National Statistics that show deaths in the UK over a year. And you can see the risk of hydrogen is very, very low. The risk of natural gas is low as well. We want to try and get hydrogen down lower than it is currently with natural gas, and we feel really confident that we can do that with a number of mitigations that I'll come on to sort of explain at the end of the presentation. But I think this is really good to just put into perspective the actual risk to society of hydrogen is starting at a very, very low point, and we believe that we can make that even lower. We've also got to take into account that as part of the H21 work, we deal with what is under the control of our license to operate as far as gas distribution networks. So we're not dealing particularly with appliances, and we're not dealing with what goes on in the home per se, although that's sort of part of our safety case, and it always has to be because there may be leaks within houses. What I'm getting at is we haven't done much research into CO poisonings and taking them as far as our statistical analysis and our quantitative risk assessment work. We don't include CO poisonings because we're just dealing with what happens on the network. The great news with that is that moving forward in a hydrogen world where there won't be any CO poisonings, there'll be an automatic further reduction in societal risk, which is fantastic. And yeah, I'll come on to tell you a slide next about the sort of history of the gas industry, and it sort of shows the journey of hydrogen, and it just sort of puts everything into perspective. If you could do the next slide, please, Katie. Yeah, I like this slide because it sort of shows the journey of the gas industry from right back at the beginning of its first inception over 200 years ago. And you look and you think, you know, for the vast majority of that time, we were producing gas from coal using retorts, and 50% of that was hydrogen. So it's only in recent times, in the 1960s and early 1970s, when we converted over to natural gas, that hydrogen fell away. So over the history of the gas industry, you know, hydrogen has played a big part in that, and it's only very recently that it's fallen off, as I've said, and now it's set to make a comeback again. And as you can see, the timescales along the bottom are sort of compressed right up. So we do have a challenge as far as moving the programme forward. We're all really up for it, and we're all really keen to sort of get through this safety phase, demonstrate that we can put hydrogen into our gas networks and we can do it safely. We can operate our networks with the same level of resilience and safety performance that we've got now, and that we can get the risk to society down as low, if not lower, than it is currently with natural gas. And that's what we've been doing over the last 4 years, and we continue to do over the next 12 months or so until we've finished phase 2 of the H21 programme. So if you could do the next slide, please. Katie, thank you. So some of the potential mitigations that we're looking at that could reduce the societal risk even further are thinking about the completion of the existing iron mains replacement programme, which is set to run for another 11 years. We could potentially do targeted additional iron mains replacement that within 30 metres of property that will reduce the risk down even further than it is now, to as low as reasonably practicable. And you've got to balance up the investment with the sort of return that you're going to get. But we feel really confident that by doing additional mains and service replacement, we can get the risk down lower than it is now in natural gas, which is a fantastic thing. As I've said earlier, the removal of the CO poisonings risk will further reduce the societal risk down, which again is a positive. The phase 2, which I've said is underway at the moment, we're looking at further risk reduction measures both upstream and downstream. There's a project sponsored by BASE called High for Heat that's been running for the last few years, and we are going to combine the outputs from their safety case work with our own. We're going to put that together so you've sort of got an end-to-end safety case, not just for gas distribution networks, but downstream of the meter, appliances and things that go on in the home as well. So overall, you'll be able to present one unified safety case for demonstrating the societal risk right from the end of the transmission system, right through the distribution system, into people's homes and down to appliances, which will be a fantastic thing. We're also working on a number of other sort of positive measures and new innovations, such as hydrogen detectors, smart appliances that could potentially detect if there's any leakage. They could inform homeowners or the distribution network or gas safe engineers that there's a problem with the appliance. So we're looking at all these things that will make people's homes much safer going forward, and whether these can be incorporated into appliances to sort of get into the Internet of Things age, if you like, and use technology that's already existing. So we're not reinventing the wheel, but we're actually putting things in place in in appliances and gas technology within people's homes that they haven't been used before. So it's just trying to take the best of what's out there and use it to reduce the risk of any injury or deaths within the home from hydrogen explosions and fires. And obviously ongoing research will continue. So our research is due to finish at the end of this year. Then the final report will be produced, and I'm sure we'll be doing some more briefings like this in about 12 months' time, giving you the overall results of the whole body of work and not just part of it. But the work will continue. The assets have been built. As I've said, Spade Adam is a fantastic facility for the gas industry to continue to do its research. We've got a couple of hydrogen homes that we've developed on our site at Low Thornley, and we've also got the HSE Science Division's site at Buxton. So further research will continue over the next few years. And yeah, we need to get the safety case for hydrogen over the line, but that will not be the end of the research. The research will continue day in, day out, as it always has done in the gas industry, and will continue to try and push the safety boundaries forward and make the gas industry as safe as it possibly can be. And that's our goal in life, and we feel really confident that we can achieve those results. Next slide, please, Katie. I think, sure if that's the end of it. Yeah, that's the end of my presentation. So yeah, I don't know if there's any questions, but thanks for listening.
Lovely. Thanks very much, Tim. There are a bunch of questions which really sort of sit down to the appliances, and I don't know how comfortable you are answering these. And unfortunately, Carl, I think, has left the meeting for the day, but I did notice that Jeff House is attending. I don't know if Jeff would like to supplement anything that you add. But the three questions really, one concerns about corrosion of the heat exchanger burning hydrogen, so higher levels of condensate, whether that is deemed an additional risk. The second question is around the calorific value of hydrogen is clearly substantially lower than natural gas, and so asking questions around the appliance output. And then thirdly, the relative efficiency of a hydrogen ready boiler. Are we compromising the efficiency of the boiler if it's burning natural gas because it's hydrogen ready?
Okay, I'll do a general summary, I think, Chris, and then I think those are quite technical. And I think Jeff's come in the chat and said he wouldn't mind answering some of the questions. So what I will say about appliances is we're working closely with BAES and bodies like Enatech and others, Worcester Bosch and Baxter, to look at appliances, to look at how we can try and make them an equivalent of the ones that run now on natural gas. We're also going to be doing some more testing at Spade Adam on internal carcassing, on meters, on pressure drops inside the house. Obviously, you need to get a lot more hydrogen down the pipe to be able to get the same amount of heat and energy out. So we're looking at all those things over the next sort of 12 months, but the actual details of the workings of the appliances, if Jeff doesn't mind coming on and answering those questions, and I'm quite happy to let him do so.
Lovely. Jeff, if you're there.
Yes, morning everyone, and thanks for the nod. Hi Tim, good intro as well. Thank you, a lot of useful information there. Okay, so on the material compatibility part and excess, or not excessive hydrogen, but we do see about 40% more condensate as a result of hydrogen combustion. Materials that we use are already, very well tested to accommodate the mildly corrosive aspects of condensate. So there's no issues there. We've done extensive life cycle testing in our lab on all the materials involved, not only from are they attacked by hydrogen, because you can have some adverse reactions with some materials with hydrogen, so we've had to change a couple of components in the gas train, but the exchangers themselves not at all. On the efficiency point, we're seeing comparable levels of efficiency to our current natural gas condensing units, so we're in compliance with the Eco Design Directive and seeing some really good efficiency figures, to be fair, which is a nice outcome, because there's a bit of work to be done to balance NOx. So we've actually managed to achieve really, really low NOx, but also pretty high efficiency. So that's a really good outcome. I understand the same is true for other boilers in development from what I've seen. Last but not least, on the calorific value of hydrogen versus natural gas. So yes, by unit volume, obviously you get less effective thermal energy from hydrogen combustion. However, because of the way in which hydrogen flows and the speed of hydrogen through the pipework and the burner itself, we can actually derive around about 95% or so of the energy that we would do, or the output, sorry, that we would do from the same sort of exchanger design that we currently have. So obviously the burner's different to accommodate that, but by and large, as Carl said, about 90% of the internal componentry of the boiler is roughly the same.
Lovely. Thank you very much for that, Jeff, and the impromptu piece. There's a question here on the colour of the flame and any thought on hydrogen use domestically, which of course the H21 programme covers. Tim or Jeff, do you want to comment on flame colorisation?
As in putting colour in the...
So I think the question states, given the colour of the flame, any thoughts of hydrogen use domestically? And I think actually on, I think it was Tommy's slides, he demonstrated a picture of the blended flame as well as the natural gas flame, and showed them to look very much the same. And there's been quite a bit of work done in the HIFA heat programme to ensure that what would be a colourless flame actually has colour to it, so that it essentially, whether you're burning it at a hob or burning it in a boiler, it will look very similar to a natural gas flame.
Yeah, I think it's a bit of a misconception that you can't see the flame. The flame may be a little bit more orangey in colour. When we open our hydrogen homes in Low Thornley, one of the things that we're going to be doing is demonstrating 100% hydrogen hobs and fires and cookers, and we're going to be asking the public what they think about the flames. Obviously, within the boiler, as a general rule, unless you sort of spy through the glass, it's not such a big issue. You know if it's on or not. I think with a lot of hobs and cookers, they're going to have LED lights, they're going to have safety features and additional things to make sure that you do know that they're lit. But you will be able to see the flame. It's not going to be exactly the same as it is now with natural gas, but we're going to do a lot of research over the next year or so in our hydrogen homes, get hundreds, if not thousands, of people to come and visit and tell us what they think about the appliances. But I don't think people should have any fears about not being able to see the flame. You will be able to do that.
Lovely. Thanks very much, Tim. Thanks very much, Jeff. And we've approached the end. So thank you to everybody in terms of their presentations today. It's been, I found it really useful. Hopefully you found it of use today, and don't hesitate to get in touch with the Gas Goes Green team at the ENA. It's good to see the important work on safety demonstrations, and as Tim mentioned in his presentation, we are proud of our continually improving safety records, and we want to bring that same level of professionalism to hydrogen and demonstrate for all to maintain that confidence of the general public in the services that we provide. So finally, if you'd like to learn a bit more about the work that we've been talking about today, we have published our Gas Goes Green hydrogen safety commitments, which you can see on the screen here, which sets out our industry-wide approach. And this is available on the ENA website, which is energynetworks.org. So thank you very much for those presenting today, and thank you very much for everybody else participating. And that draws this workshop, this summit, to a close. Thank you very much.
Thank you.